evening, all. I hope you're doing well. We're going to go over our study guide and kind of just see if where you have questions at, follow through with this, mark or something else. Hopefully this kind of helps you if you get stuck on one of the problems. Well, let's just get to it. So first off, the number one says how many moles of HCl are required to produce 7.5 moles of zinc chloride. So this means what's happening is I am looking at how many moles of hydrochloric acid I'm looking for. And I'm looking from how much is going to be produced from 7.50 moles of zinc chloride. So this is what I am looking for. So first off, if you look, zinc chloride and obviously hydrochloric acid are not the same thing. So I had to look for a balanced chemical equation between the two. And that's just right above it. So you just need to make sure it's balanced. So I look at zinc, zinc's 1 and 1. I look at hydrogen, hydrogen's a 1, 2. And chlorine is a 2 and 1. So I'm going to have to fix my reactant side with a coefficient of 2. And this will fix not only my hydrogen, but also my chlorine. Leaving zinc and that is 1. So these will have 1s. So that's my balanced chemical equation on that. Then we'll start with what I have. So I'm starting with 7.50 moles of zinc chloride, and zinc chloride is ZnCl2. Alright, so it's saying how much it's going to produce 7.5 moles of zinc chloride, so that's my product. Now, I need to convert it into moles of HCl. So since it's moles, I already start with moles, then I can go directly to a mole-to-mole conversion. So mole of HCl is where I'm going to, and where I came from is moles of zinc chloride. All right, now I go look at my balanced chemical equation because this is where I get my mole ratio from. So I look at HCl, and HCl is 2, and zinc chloride is 1. So I'm going to do 7.50 times by 2, divided by 1, and this gives me a wonderful total of 15 moles of HCl. And I can stop right there because all I wanted was moles. So this is my answer. All right, next. How many grams of oxygen are required to produce 7.5 moles of aluminum oxide? So I'm trying to produce 7.5 moles of aluminum oxide. This is right here, your aluminum oxide. And it's asking me how many grams of oxygen was needed in order to do so. So first off, once again, I'm comparing two different types of substances, so I need a balanced chemical equation for them, so I have a relationship. So in this case, I have 2 aluminum and 3 oxygen. So let's start with our aluminum. So we have 1 on our reactant side, 2 on our product side, so that means I need a 2 here. Now I got to balance out my oxygens. Well, this means I need to change my oxygens where they'll have the same variable. In this case, 3 and a 2, so the closest one is 6. Well, this ends up causing me to do a 3 and a 2, which tells me then I actually have to change my aluminum because I have 2 and 2. So if you make a mistake like that, it's not a big deal, right? Because you can just erase that coefficient and put the proper one there. So for now, you have 4 aluminum and 4 aluminum on both sides, 6 oxygen and 6 oxygen. Okay, so now that we're balanced, let's get to our equation. So we start out with 0.75 moles of aluminum oxide. All right, then we got to do our picket fence. And now we have on the top goes where we're trying to go. So we're trying to get to oxygen. So we need to put moles of oxygen at the top from moles of aluminum oxide. And we look at our balanced chemical equation to find what our ratio is. So oxygen is a 3, aluminum oxide is a 2. So we need to then multiply by 3, divide by 2. And this will give us a lovely total of 1.125 moles of O2. Now, that's great. I have moles, but it wants it in grams. So I need now convert that moles to grams. So if you look at your mole wheel, you should understand that going from moles to grams means I need to find my molar mass of oxygen. If you look at your periodic table, the moles for oxygen is 16. And since I have 2 oxygen, that means I actually need 32 grams of oxygen for 1 mole. of oxygen. All right, now I do 1.125 times by 32, and that would give me a wonderful total of 36 grams of oxygen. Next one. How many moles of potassium chloride are produced in 119 grams of potassium bromide? Well, first off, I notice I have grams of potassium bromide, and I need to turn it into moles of potassium chloride. But I can't do that with grams, so I need to convert grams of potassium bromide to moles of potassium bromide. So we're going to do that first. So I have 119 grams of potassium bromide, and I need to convert it to moles of potassium bromide from grams of potassium bromide. This is where I need, once again, my molar mass, because molar mass is how many grams per mole. So in 1 mole, there's 119 grams of potassium bromide. Well, this makes it easy, because 119 divided by 119 is just 1 mole of potassium bromide. After that, now I got to turn from moles of potassium bromide to moles of potassium chloride. So moles of potassium bromide. Oh, chloride, excuse me. Oops. Gotta put chloride at the top because that's what we're looking for. From moles of potassium bromide. And in order to do this, I have to have a mole ratio. So I have to balance my chemical equation. So I look at my chemical equation. I have 2 on my reactant side of chlorine, 1 on the other side. So I need to put a 2 here. From there, I need to change to 2 potassium and then 2 bromine. So I end up having a 1:2:1 ratio. So now I look at my potassium chloride and I say, okay, that's a 2. Potassium bromide is 2. So that's a 2:2, the same as 1:1. That means I end up with 1 mole of potassium chloride. And then I'm done. Okay, next one. Change the color, just give you a different look. All right. How many grams of copper, so I'm looking for grams of copper, are required to form 750 grams of silver? So I started with my product, and I need to find how much reactant was needed for this. So once again, you can use the BCA table, and this one, maybe we'll actually do the BCA table just so you can kind of see how it works. But you need to understand BCA table is just a tool, right? But no matter what team you're using the BCA table, you can't have grams. You need to convert into moles. So we need to start with moles of silver. So we say we have 250 grams of silver, which is Ag, and we need to convert it to moles of silver. So moles of silver from grams of silver. And in this case, it's our molar mass again. We need to find the relationship between moles and grams, and we use molar mass of silver. Molar mass of silver is 107 point. Let me give myself more room. 7.87 grams of silver to 1 mole of silver. All right, do all that math, and I end up getting 2.318 moles of silver, which should make sense because if I look at 1 mole, I would get 107.87 grams. And obviously, I have more than 107.87. I have a little over 2 times the amount, so that's why my mole is more than 2 moles. Okay, so now that I have that, I can either use my mole conversion like I've done above, or I can set up a BCA table. And this is good, especially when you have more than 1 gram value. But just to remind you, we're going to set it up. So first off, I had to balance my chemical equation. So let's do that. So I have 2 nitrates on my product side, so I need 2 nitrates on my reactant side. That changes my silver to 2, so this also changes my silver to 2 over here. I look at my coppers are still 1:1. Then that means these get 1s. Easy peasy. All right, next one. So now I'm going to transfer this over so I can set up my BCA. Oh, set this up really quick. All right, so now that I have my BCA table, my B, C, and A, now I just got to put what I start with. So I'm starting with moles of silver. And since it's a product, that means I had to produce 2.3 2.318 moles. That means I ended up adding 2.318 moles. So I'm working myself backwards because, right, all products start with 0. Now, you can fill out this whole BCA table if you like, but on this one, we're just looking for copper. So we need to convert moles of copper got moles of silver to moles of copper. So I look at this and I say, okay, I'm going to use this as if it was my limiting reactant, and I go 2.318 times by the coefficient of copper, which is 1, divided by the coefficient of silver, which is 2. So at that point, I'm just doing 2.318 divided by 2, and you should get a wonderful total of 1.159 moles of copper. And this would be used, so it means I at least had to start with this amount. Right, so that means I have 1.159 moles of copper, but I didn't want to stop at moles because I wants me to find grams. So I need to find grams of copper, right? So I got to go from moles to grams now. So we go back and we say, okay, cool, I'm starting with 1.159 moles of copper, and I'm converting it into grams of copper from moles of copper. And we do grams to moles. Moles is always 1 because we're always comparing to 1 mole. I look at the molar mass for copper, and your molar mass for copper should be 63.55 grams. Okay, then from there, that gives me, I multiply the top, divide by the bottom, which gives me a lovely total of 73.65 grams of copper. That is my final answer. Remember, if you run out of room, always use a second piece of paper, right? Sometimes I know with all this stuff that we're giving you, it's not always enough room to do it. Don't be afraid to use another piece of paper. All right. I'll try in the future to give you a little more space, but I don't want you guys to get so bombarded how many pages there are. Okay, so next one. It says how many grams of magnesium nitrate, so I'm looking for grams of magnesium nitrate, are produced from 7.5 moles of nitric acid. So first I have to figure out what nitric acid is. And if you forget, acids always begin with the hydrogen. But if you forget, you can just break it down step by step. Maybe I'm not sure how to name this one. So I go to the next one, you should know how to name. Well, I look up Mg. Mg is magnesium, and OH is a hydroxide. So this is magnesium hydroxide. Next one is magnesium, and NO3 is nitrate. So magnesium nitrate, and H2O you know as water, or dihydrogen monoxide, right? So the only possible one then is the HNO3, which is our nitric acid. So we're starting out with moles, and we need to get to grams. Well, luckily, if we're starting with moles of nitric acid, we convert it to moles of magnesium nitrate, and then grams of magnesium nitrate. So first off, I have to start with a balanced chemical equation then. So I look at this question, and I say, okay, I have on my reactant side 2 nitrates, so I need 2 nitrates on my reactant side, and I have 2 on my product side. So I need a 2 here. This now changes my hydrogen. So I look at my hydrogen. I have 2 hydrogen here, but I also have 2 hydrogen here. So that's 4 hydrogen altogether. So that means I need to make my product side 4 hydrogen. So I'm going to multiply that by 2. Now this changes my oxygen to 2. And I have 2 oxygen on this side as on my reactant side. So now I don't really need to change anything because magnesium is 1 and 1. So that means these have a coefficient of 1. Now I can do this in my head, but always you can break down the chart. You can do the T-chart. You can set it up however you want and balance it. Either way, you can keep track of your numbers. Okay, so now let's start by converting moles of nitric acid to moles of magnesium nitrate. So I'm starting out with 7.50 moles of nitric acid, which is HNO3. And I'm going to use my picket fence to set up my mind where it needs to be. And I'm going from moles of nitric acid to moles of magnesium nitrate. And so I need moles of MgNO3, and that's going to be 2 there. And I'm converting that from moles of nitric acid, so HNO3. And now I look at my balanced chemical equation, get my ratio, and so I look at magnesium nitrate, that's a 1, and then nitric acid is 2. So I'm going to multiply by 1, divide by 2, and you should end up getting a grand total of 3.75 moles of magnesium nitrate. Now it wants its total in grams in, so we're not done yet. So then we need to do another picket fence. And we say, okay, now I need to get to grams of magnesium nitrate from moles of magnesium nitrate. And you can do this because there's a relationship between grams and mole, which is our molar mass. So you have to calculate the molar mass of magnesium nitrate. So you would have to add the mass for magnesium, 2 nitrogen, and 6 oxygen. And if you do this correctly, then you should end up with a molar mass of 148.3 grams. All right, then you multiply the top, divide by the bottom, and in this case, you should end up with 556.13 grams of magnesium nitrate. Okay, next one. So I said how many moles of silver chloride are produced from 1,159 grams of silver nitrate. So I'm converting one thing into another, so from silver nitrate to silver chloride. So I need a balanced chemical equation. I go ahead and look at my balanced chemical equation. I see I have 1 silver on my reactant side, 1 silver on my product side. 1 nitrate on my reactant side, 1 nitrate on my product side. 1 sodium on my reactant side, 1 sodium on my product side. 1 chlorine on my reactant side, 1 chlorine on my product side. So that means everything's balanced, and this is just a 1-1-1-1 ratio. Very exciting because it makes some math kind of easy. So first off, though, in order to convert one thing to another, we need to convert grams to moles. Always, if you have two different substances you're trying to compare with each other, you're going from grams to moles first. So you need 1,159 grams of silver nitrate to moles of silver nitrate from grams of silver nitrate. And I have to get the molar mass then of silver nitrate, and your molar mass is 169.87 grams. So multiply the top, divide by the bottom, and you'll end up getting 6.823 grams of silver nitrate. Okay. After that, now I have to convert it to moles of silver chloride. So I now can, it's not grams, it would be moles. Whoopsie. Mine wasn't working there for a second. Moles. Right, because grams and grams canceled out, and now that leaves you with moles. All right, so now you go from moles of silver nitrate to moles of silver chloride. So I'm looking for moles of silver chloride. Moles of silver chloride goes on top of the fence. From moles of silver nitrate. Well, it's a 1-to-1 ratio. That means the mole value doesn't change. It still is 6.823 moles of silver chloride. Okay, and that's it for that one. Next. All right, so it says how many grams of phosphorus trichloride are produced from 85 grams of phosphorus. So I'm going to start by balancing my chemical equation. I have 4 phosphorus on one side, 1 phosphorus on my product side. So I'm going to put this to a 4. This makes it where now on my product side I have 12 chlorine. Well, I had to figure out how many times 2 can go to 12, and that's 6. And that means that's a 1. So my ratio is a 1:64. And then I will convert grams of phosphorus to moles of phosphorus. So I do 85 grams of phosphorus and convert to moles of phosphorus because I'm trying to go from phosphorus to phosphorus trichloride. So I need moles of phosphorus at the top from grams of phosphorus. And I need to see how many grams of phosphorus are to 1 mole. So I have to take phosphorus and multiply by 4 times. And this gives me a grand total of 123.89 grams. And this then totals out, after I do my wonderful math, to 0.6861 moles of phosphorus. Now I have to go from moles of phosphorus to moles of phosphorus trichloride. So now I'm going to moles of phosphorus trichloride to grams of, or excuse me, whoopsie, from moles of phosphorus. So when I get this, I get my ratio from my balanced chemical equation. This is a 1:4 ratio. So now I'm going to multiply 0.6861 times by 4, and you should end up getting a total of 2.744 moles phosphorus chloride. Now you're going to convert that into grams because it said it wanted in grams. So I need to convert it to grams of phosphorus chloride from moles of phosphorus chloride. And I need to figure out how many grams are in 1 mole of phosphorus chloride. So after you calculate the molar mass, you should end up with a grand total of 137.33 grams. And after I do this math, that gives me a total of 376.83 grams phosphorus chloride. Now, if you have any questions or you see that I do math wrong somewhere, just let me know, right? I'll gladly fix it. All right, let's move on to the number 8. Let's change color again here. Let's go dark blue. Why not? All right. It says when 35.75 grams of potassium nitrate, so this is what I'm starting with, potassium nitrate, and it's right here, it decomposes, means break down. This is a decomposition reaction. All right, you start with one reactant, breaks down to multiple products. How many moles of potassium nitrate are formed? So we're looking for how many moles of this are here. So we're starting with grams. We need to instantly know we got to convert grams to moles in order to turn one substance into another type of substance. So I'm going to have 35.75 grams of potassium nitrate. And I need to convert it into moles of potassium nitrate from grams of potassium nitrate. All right, and I look up the molar mass for potassium nitrate. If you look that up, you should end up with 101.1 grams per 1 mole. Once I'm done doing this, I do my math, and I get a total of 0.3536 moles of potassium nitrate. Now I got to convert it into moles of potassium nitrite. So I'm trying to get to moles of potassium nitrite, which is KNO2, from moles of potassium nitrate. So first thing I gotta do is make sure I have balanced chemical equation. So if I look over here, I have oxygen in 2 spots, and I have oxygen in 1 spot on my product side. But also though, I also have nitrogen and potassium that are also in my product side. So obviously my oxygens aren't going to be easy to balance. So I have to think, what ratios can I increase my reactant side in order to just change my product side one time, so that way they balance each other. So let's say I say, okay, well, I can see 3 and 2 are usually into 6. So if I put a 2 here, that gives me 2 times 2 is 4, plus the other 2 oxygen over here will give me 6. So that looks like it possibly works. So that means we end up having 2 potassium. So I need a 2 over here at least. So I have 2 potassium on both sides, 2 nitrogen on both sides, 6 on my reactant side, and then 6 oxygen on my product side. So then I'm good. So it's a 2-to-1 ratio. So between these, it's a 2 and 2 ratio. So that means I'm just pretty much a 1 and 1. And now I end up with 0.3536 moles of potassium nitrite. Okay, moving on. So it says if 9.5 grams ammonium fluoride are reacted with excess aluminum chloride. So this just excess means there's more than enough aluminum chloride right here to react all 9.5 grams of ammonium fluoride, which is here. How many grams of aluminum fluoride can be produced? So I'm looking for grams. Look for grams of aluminum fluoride. So first off, I'm converting something into something else. That means I have to convert grams into moles first. So I have 9.75 grams of ammonium fluoride. So NH4 with an F. And I need to find the molar mass now because I'm going from moles of NH4 of ammonium fluoride from grams of ammonium fluoride. And so this is a 1. And I look at the molar mass for this, and you should get a total of 37.04 grams. And when you calculate this should give you 0.2632 moles of ammonium fluoride. Now I got to convert moles of ammonium fluoride to moles of aluminum fluoride. So I need to go from moles of aluminum fluoride from moles of ammonium fluoride. Okay, so in order to do this, I need a mole-mole conversion from my balanced chemical equation. So let's go look at our balance. So let's see, I have 3 chlorine on this side. I only have 1 chlorine on my product side. So I want to change this to a 3. Now that I change this to a 3, this changes my chlorine to also a 3, but also changes my ammonium to a 3. So I need to make sure my ammonium's a 3 on my reactant side. I look and it's only 1, so I put another 3 over here. This changes my ammonium to also have a 3, but also my fluorine to have a 3. So I go look at my product side, and fluorine's already a 3. Aluminum's a 1 to 1, so these just get 1s. So my ratio is a 1-3-1-3 ratio. So I look at aluminum fluoride now, and I see that's a 1, and ammonium fluoride, and I see that's a 3. So I'm going to do 0.232 divided by 3. And when you do this, you will get a total of 0.08773 moles of aluminum fluoride. And I go, if you notice, I went out a few more digits. Usually I go 4 sig figs, but it's still 4 sig figs. Remember, these first zeros don't count. Okay, so now that I have moles of this, now I got to convert it into grams, because that is what my final answer needs to be in. So I need to go to grams of aluminum fluoride from moles of aluminum fluoride. It's always 1 mole. I look at the molar mass for aluminum fluoride, and it's a 3.98 grams. Now I multiply top divided by the bottom, and that gives me a total of, let me put it over there, 7.37 grams of aluminum fluoride. Okay, that's my answer. Move on to the next one. So it says how many grams of water, so I'm looking for water, will be produced from a decomposition reaction of 78.5 grams of sulfuric acid. So once again, I got to go from grams to moles. So I need to get to sulfuric acid. Acids always begin with hydrogen, and since it's decomposed, I know this is the only one it could be. So I need to go to 78.5 grams of sulfuric acid to moles of sulfuric acid from grams of sulfuric acid. So I need to look up the molar mass for sulfuric acid, and you can calculate this from the periodic table, and you would end up getting 98.08 grams per 1 mole. And then when you calculate this out, this is going to be 0.8004 moles of sulfuric acid. Now I need to turn it into moles of water. So moles of H2O from moles of sulfuric acid. And I need to see how many moles. Well, that means I need to balance out my chemical equation. So if I look over here, I have 2 hydrogen on my right side, 2 hydrogen on my product side. 1 sulfur, and 4 oxygen, and 1, and 3 is 4. So I'm balanced. So this is all just a 1, 1, 1. All right, so it's a 1 to 1. That means my moles of water is going to be the exact same as my moles of sulfuric acid. Okay, and it asked me to find grams of water though, so now I got to do grams. So once again, you're looking for grams of H2O, and you're getting it from moles of H2O. We know this is going to be molar mass, so our molar mass for water is 18.02 grams for every 1 mole of water. And we multiply top divided by the bottom, and this gives us our total. I'll write it up here this time. This gives us a total of 14.42 grams of water. So if hydrosulfuric acid decomposes, you would end up getting 14.42 grams of water if you started with 78.5 grams of hydrosulfuric acid. All right, go on to the next one. A single replacement reaction is started with 10.7 grams of hydrochloric acid. Change colors a little bit. How many moles of beryllium chloride will be formed? So I'm just starting with my grams of hydrochloric acid, and I need, since I'm comparing 2 different substances, that means I have to go to moles. So I go 10.7 grams of HCl, and I'm going to moles of HCl. So I need to go from grams of HCl to moles of HCl. That means my comparison between moles and grams is our molar mass. So 1 mole of HCl, there is 36.46 grams of HCl. That's 1 hydrogen, 1 chlorine added together. And you multiply the top divided by the bottom, and when you get this, you end up getting a total of 0.2937 moles of HCl. Now I got to go moles of HCl, and I need to go to moles of beryllium chloride. So I set up my thing and my picket fence. So I'm going to moles of beryllium chloride from moles hydrochloric acid. So in order to do this, I need a mole to mole ratio. It means I need to balance out my chemical equation. So I look at this, beryllium's 1 and 1. We're good so far. Hydrogen's a 2 and 2, and chlorine's a 2 and 2. So that means I need to add a coefficient of 2, and that will fix everything. So this is a 1:1:1 ratio. So beryllium chloride is 1, hydrochloric acid is 2, so I'm going to divide by 2, this means. And you should get a total of 0.1469 moles of beryllium chloride. Okay, now moving on to the next one, because we don't need to convert grams, because just wants moles. All right, let's go purple this time. Okay, so when this reaction is run with 74.5 grams of copper 2 sulfide, what mass in grams, which mass just means what is the mass, and you want it measured in grams. So don't get caught up with all that. You just find grams of copper 2 oxide it will be produced. So once again, you're comparing 2 different substances. So because of this, you have to go from grams to moles to mole to mole to moles to grams, since this one's asking for grams, not just the moles. So no matter what, start out with our gram value. So we have 74.5 grams of copper 2 sulfide. So this is copper 2 sulfide. And I am going to convert it to moles of copper 2 sulfide from grams of copper 2 sulfide. All right, so 1 mole, I have to look up the molar mass for copper 2 sulfide, and that's going to be 95.62. Once again, you calculate this from your periodic table. And I'm going to multiply the top, divide by the bottom. 0.7791 moles of copper sulfide. All right, now I need to go from moles of copper sulfide to mole of copper 2 oxide. So, moles of copper 2 oxide from moles of copper 2 sulfide. So that means I need a balanced chemical equation. So I look at this. I have copper is 1 on my reactant side, 1 on my product side. So over 1 on my reactant side, 1 on my product side. And oxygen, 1 on my oxygen, 1 and 1. So it's all literally just a 1, 1, 1 ratio since everything's balanced. So that means this is going to be the copper oxygen and copper oxide and copper sulfide have the same mole value. 7791 moles of copper oxide. Now I need to convert this into grams though, so I'm not done. I need to go to grams of copper 2 oxide from moles of copper 2 oxide. Always going to be 1 mole, and I look at the molar mass and find the molar mass from a periodic table, and that's going to be 79.55 grams. Now I multiply the top, divided by the bottom. Let's put my total down here. That gives me a total of 61.97 grams of copper oxide. All right, only a few more left. Let's keep going. Hopefully you guys have some of this done so you're not having to watch every single moment of this video. Remember, this is just to help you out if you get stuck. All right, last couple. If 35.6 grams of iron 3 oxide, so I'm starting with this, react with the excess aluminum, that means that there's just more enough aluminum to complete this reaction and complete all 35.6 grams of iron 3 oxide. How many grams of aluminum oxide will be formed? So once again, I got to convert my grams of iron 3 oxide to moles because I'm converting it into aluminum oxide. So I need to go from grams to moles. So 35.60 grams of iron 3 oxide, which is iron. There we go. And I need to convert it into moles of iron 3 oxide from grams of iron 2 oxide. So I look at my periodic table. I figure out what my molar mass is for iron 3 oxide is. So that's 2 irons and 3 oxygens, and that's 159.86 grams. Multiply top, divide by the bottom, and this gives me a total of, oops, sorry, that went all weird for a second. This gives me a total of, there we go, 0.2227 moles of iron 3 oxide. All right, now I got to convert it into moles because I want grams, but I got to get to moles first. 2 moles of aluminum oxide. So moles of aluminum oxide from moles of iron 3 oxide. Okay, so this means I need a mole to mole ratio, which I have to balance my chemical equation. So I have 2 iron on my reactant side, 1 iron on my product. So I need to change that to a 2. Then I have 3 oxygen and 3 oxygen, and then I have 1 aluminum, then 2 aluminum. See that 2 aluminum there. So I need a coefficient of 2 over here, and these will be 1s. All right, so I look at my aluminum oxide, and this is a 1:1 ratio. Makes life easier. So that means I end up with the exact same mole value, 0.2227 moles of aluminum oxide. So now I got to go from moles of aluminum oxide to grams of aluminum oxide. So grams of aluminum oxide from moles of aluminum oxide. I looked this up or calculated from my periodic table, and you should get a total of 101.96 grams to 1 mole. Multiply top divided by the bottom. We'll put our answer down here. And if you calculate that right, you should end up with 22.71 grams of aluminum oxide. There we go. That is our answer. All right, and last few. Let's go. Let's go lighter blue. Why not? All right, when this reaction is run with 7.765 moles of lithium hydroxide, how many moles? So we're starting with this. How many moles of magnesium hydroxide would produce? So I have two different substances once again. So and then you go to moles. Luckily, I have moles. So I literally just have moles, 0.765 moles of lithium hydroxide. And I'm going to convert it into moles of magnesium hydroxide from moles of lithium hydroxide. All right, so I need a balanced chemical equation then. So if I look at this, one lithium, two hydroxides though on my product side and one on my reactant side. So I need to change that to a 2, which that matches my hydroxides. But my lithium is off, so I need to put a 2 over there with my lithium. That changes my chlorine to 2, but I already have 2 over here. So that's perfect. And magnesium is 1 to 1, so those get coefficients of 1. So it's a 2-1-2-1 ratio. So I look at my magnesium hydroxide, that's 1. Lithium is 2. That means I'm multiplying by 1, dividing by 2. And you end up with having a molar mass, or excuse me, not molar mass, the mole value for magnesium hydroxide is 0.3825 moles of magnesium hydroxide. And that's it. That's all you got to do for that one. Next one. Last but not least, let's go red. Why not? All right. So a double replacement reaction runs with 16.5 grams of calcium chloride. How many formula units? So this is different. This is not grams. This is, remember, formula units is just another thing for particles or atoms or molecules, right? The only reason it says formula units is because it's an ion, or excuse me, yeah. It's a ionic bond. There we go. It's ionic bond. Sorry, it's late. All right, silver chloride. So I'm trying to find my particles in this case. So, but nonetheless, though, I still have to go to my moles, because if you look at your mole wheel, in order to get to particles from grams, you have to go grams to a mole. And since it's two different substances, right? Two different substances, that means you have to go from grams to moles, a mole to another mole, and then a mole to our formula units. So we got to still convert grams to moles. So we have 16.5 grams of calcium chloride, 2 moles of calcium chloride from grams of calcium chloride. So you got to look at that molar mass, how many grams are in 1 mole, and we get 110.98 grams. And I multiply top divided by the bottom, and you end up getting 0.1487 moles of calcium chloride. All right, now I got to convert it into moles of silver chloride. So moles of silver chloride from moles of calcium chloride, which means I have to have mole to mole ratio, so I need to balance my chemical equation. So I look at calcium. Calcium is 1 and 1 on both sides. I then look at my chlorine. Chlorine's 2 over here, but 1 over here. So I have to fix my chlorine. So I'm going to add a coefficient of 2 over here. That changes my silver to 2. Well, my silver here has 1, so I need to change that to 2. And my nitrate now has 1, or excuse me, has 2, and I have 2 over here. So that means this is a 1, and my ratio is a 1-2-1-2 ratio. All right, so silver chloride is a 2 then, and calcium chloride is a 1. So I'm going to multiply 0.1487 moles of calcium chloride to moles of silver chloride. And you will get a total of 0.2974 moles of silver chloride. And now I gotta convert this into formula units, which is our Avogadro's number, right? So we gotta get to formula units. So we know every single mole, no matter what it is, has 6.022 times 10 to the 23rd particles, which in this case is formula units. And so we multiply this together, and you will get a total, let's put the total down here, of 1.79 times 10 to the 23rd formula units of silver chloride. And that is all. So hopefully this was helpful, taking you step by step how to do this. Hopefully you took notes or you labeled any questions you have, and I hope you have a wonderful evening. So stay savvy. Talk to you soon.